Good morning, folks. Jim Giacchetta here from VidOvation. I'm glad you guys have taken time out of your busy work days to spend some time with us. We're going to try to keep this short and brief. The point of this particular presentation is just a basic overview of video networking, IPTV. I know there's probably some of you guys out there that want a deeper dive into things or get into more details, and we will dive deeper into these subjects once every 2 weeks. We have another 5 segments scheduled that will dive into IPTV for a particular application, whether it's broadcast, corporate, medical, hospitality, government, and military. So you can see online under our events page. Be sure when we're done today to register for these more in-depth presentations. With that said, I mean, feel free to ask questions. If they're within the scope of this particular presentation, we'll try to answer those. We can answer more detailed questions offline afterwards, or stay tuned for some of the more in-depth presentations to follow. So let me move forward here. All right, there we go. So here we have a basic video networking or IPTV system. One of the difficulties that I have is that a lot of people define IPTV differently, or IPTV, which is short for Internet Protocol Television, has many different definitions and many applications. We fundamentally think of it as video networking, whether that be on a private dedicated network or on the public internet. So wide diversity of applications, different types of networks, different types of protocols. So to bundle everything under IPTV is a very broad and general statement. So what we have here, when we speak of IPTV or video networking, it's usually on a private network, a dedicated network, or on the corporate enterprise, not the public internet. So in this type of application, we have the ability to set up multicast, and we can stream our video via multicast as opposed to unicast. And what that allows us, we can have thousands of subscribers on the network simultaneously viewing one stream. So we economize bandwidth. And multicast streams, when they're sitting out there on the network, they only send traffic to a given port when that traffic is requested. So you could have 10,000 employees on your enterprise network sitting at their desks. They could watch live and pre-recorded TV with a desktop player, but say only 10% of the people are watching television at that given time. We're not clogging the whole network with that video traffic. The multicast streams just sit in the backbone of the network, and they don't come down the segment or to your port on your display device until it's requested or needed. So that's the ideal scenario. And the problem is that the internet as it is today is a unicast protocol. So if you want to stream video across the internet, you have to have an individual stream for each user. So if you're streaming some live webinar, or we do a lot of work with churches, so a church wants to broadcast to 10,000 people through the internet, those are all unicast streams, and I'll get into how you can achieve that. But in this scenario, back to the corporate application, this is a controlled and managed network. We can predict the bandwidth capabilities. We'll have a certain backbone going through the network. We can assume that all the appliances, all the set-top boxes, all the desktops, all the smart devices that will be accessing this video can support a given bit rate or 1 bit rate. And typically the transmission protocol is simplified because it's a reliable network with certain guaranteed bandwidths. We don't have to worry about packet loss, so we don't have to have forward error correction. So we turn on multicast, we multicast enable our network, and we're good to go. We have a controlled, nice controlled environment. So let me go to the next screen. So here's another application. So the previous application, we could have live TV coming in from the outside world. We could have the CEO of a corporation wants to give a speech, so we could have an encoder and a camera fixed on him to make a speech. We could have pre-recorded video on demand that we stream across the network. But in a broadcast environment, maybe someone wants to just monitor the feeds in the facility or feeds in the plant. So you could have multiple videos inside the plant, or you want to set up an internal television system where people can watch different videos, even security cameras, that sort of thing. So there's a monitoring aspect. So there's an educational aspect, training, monitoring, all these functions come into play. We get a lot of requests now too. People want to bundle digital signage in with this technology. So it makes sense. If you have televisions or displays in public areas, lobbies, break rooms, conference rooms, when those displays are not being used for live TV, you may want to have advertisement. If there's some restaurant in the building that may want to advertise the lunch specials for that day, or if in a corporation you may want to advertise an HR meeting or upcoming events, vacation closures, that sort of thing, or just news crawls at the bottom of the display with live video superimposed. So there's all kinds of applications, all kinds of needs for streaming live and pre-recorded video on the network. So so that's on the private network. Now, if we want to go out on the internet, if we want to do something like this where we want to stream to the internet, maybe we want to stream video to remote offices, or our customers are in remote locations. We want to do some training. So we want to go through the public internet. How do we bridge the gap to get to the client? If you need, we could set up our own web server so that we could stream multiple unicast streams. Unicast, those individual streams for each participant or each viewer. If you need to reach thousands or millions of viewers, you would use a content distribution network or a CDN. But how do we get the video from our facility through the firewalls up to the CDN? Well, one of the popular transmission video streaming protocols right now is HLS, and that's HTTP live streaming. And what's nice about this is it's actually emulating website traffic. The internet was invented for web servers to stream information to people, to their browsers. And typically this traffic goes through port 80 on everyone's firewall, whether you're a corporation or at your home. We all have firewalls that face the outside world or the public internet. And the novel idea was invented that, hey, why don't we make our video traffic look like website traffic? So hence the HTTP live streaming, or HLS. And the interesting thing is that the infrastructure is already there. A web server is very good at streaming content or delivering content to millions or thousands or millions of viewers. We know how to do that. The IT world knows how to do that. You know, and we can transmit, you know, TCP protocols over an HTTP connection. So the marriage of this, or this technique, is ideal. We don't have to get IT involved if we want to go through a firewall. This is known as part of this, we have adaptive streaming technology. So what that means is you could take some VidOvation encoders, or anyone's encoders for that matter, but our encoders are set up for this, where we could deliver multiple resolutions, multiple bit rates in the HLS format. And what we do is we break them up into little files, so tiny little bite-sized chunks. And you can see we stream them, or we FTP them to a traditional web server. So we don't need a media server anymore. We just use a regular web server. And these snippets of video streams, these little packet-sized files sit out there. There's playlists that tie them all together. And what the media player does, whether it's your set-top box or the player on your iPhone or on your desktop, is it senses this connection speed between you and the server, and it makes it says, oh, well, wait, I can handle a 1 megabit per second stream, so I'm going to start reading these files. Then the connection goes south. You know, you're on your cell phone and you're moving around. Oh, the connection goes bad. The player will sense the bandwidth reduction and switch to, you know, instead of grabbing the next file here, 566, it'll jump to the 500K file, and so on. And then if it senses that, hey, I'm playing these video files faster than they're coming to me, so I can handle more bit rate. So then it jumps back and forth, and it's completely adaptive. So HLS is very common on Apple devices, set-top boxes, Microsoft Silverstream is very similar. That's used more on PCs. I'll also get into the Flash protocol, again, which Flash devices, the Flash player does not work on any Apple handheld or tablet device, so HLS is really the only option. So it makes it more difficult for us when we're delivering video to the public. We have to adapt to the kind of device that they're using. We can either have encoders in our frame here. You know, you could have VidOvation encoders, one streaming out HLS, one set up for to go to an Adobe Flash media player or media server. So we can have these multiple protocols available depending upon the device, or CDNs now can provide this type of transcoding. So you can send up one form of video stream, you know, maybe a common thing like H.264. So we would stream that up to the CDN, then they would transcode and deal with providing HLS and some of the other type formats. So let me keep moving here. So, you know, so here's another application. You know, we want to get through the internet. Now, the other problem with the internet is, as we all know, the internet is not always reliable. So what do we do about that? So packets get dropped, unusual delays. You know, certain packets might be delayed for long periods of time, and then they get timed out. They die, or their time to live. They exceed their time to live, so the packets get destroyed because it's a traffic jam out there. So our encoders, you know, and everyone does this. You know, there's the SMPTE 2022 forward error correction. So when you're going through the public internet, it's highly recommended to use one of these protocols to if a packet is lost or interrupted, that with forward error correction we can recover long strings of packets that get lost. So instead of waiting indefinitely for a packet, you know, buffering the video or buffering the packets, we can regenerate those lost packets and tolerate a certain amount of loss through the network. And we can help you with this capability. Then here's other applications. So here we are on our corporate network, and this is common where multiple TV stations, their affiliates, they want to connect together. So the main corporate headquarters or the main TV station or the main television network, they want to make their own internal television IPTV live TV distribution network. So how do we connect multiple branches together or multiple locations? So within the main corporation, we can set up our multicast enabled network. We could have a multicast enabled network at the remote side, but many times the connection between the networks is not multicast enabled. So we have devices where we can grab the multicast streams and convert them back to unicast. So if the WAN between the two networks, certainly if it's the public internet, we would have to definitely convert it back to unicast. So we would have to have a fat enough pipe. So say we have like 100 channels of video here, and they're 100 megabits per channel. We would need a very fat pipe to get through here because we can't. We have to put all 100 channels through simultaneously. Then when we get to the other side, we can split them. We can convert them back to multicast. So this particular user down here doesn't see all 100 channels on their network connection. They only stream the channel that they want when they want it. The multicast channel will come through. So we can kind of bridge the private and public networks. This might be a telco circuit here, a very high quality circuit, or like I said earlier, it could be the internet. And then we probably would want forward error correction turned on this segment. So we can, the technology is available now that we can stream to the desktop, so you can see all your live television, all your video on demand in a media player. There's no special player. It all just works in virtually any browser. If there's televisions in the break rooms or in public areas, we like to use a little Amino set-top box. It's a kind of an open standard set-top box. Most of what we do at Multidyne, at VidOvation, I'm sorry, Multidyne was my old company, sorry about that. At VidOvation, we try to keep open architecture. So we like to use the Amino. We use protocols that are open architecture. Of course, we'd love you to use our encoders, but we're not the only manufacturer of encoders. We are one of the few, though, that are capable of streaming to the desktop. That is very unique for IPTV and video distribution. So another protocol or another way of moving video, I alluded to it earlier, is the Adobe or Flash player. And the whole RTMP or real-time messaging protocol was developed by Macromedia years ago for streaming audio and video and data over the internet. Not too long ago, Adobe acquired Macromedia, so now it's part of the Adobe suite of capabilities. And you can get an inexpensive encoder from Adobe. You can download it. Anyone can do it. It's a very stripped down encoder, so if you want to stream and use a software desktop type encoder, you can use these shareware or free encoders, and you can get, the Flash player is available to anyone. But the problem with Flash is that it does not play on Apple devices. I've heard war stories that Steve Jobs contracted Adobe to develop some software for them, and they had some falling out. So I think it was kind of a political decision that not to support Flash on some of the Apple devices, but that's for another day. Us engineers in the industry, we got to make this all work. We don't get into the politics of why one standard is chosen over another. We just got to make all the different devices work nicely together. But back to Flash, it's very widely used. Adobe has media server softwares, which is very popular. Your CDN may prefer to stream you flash content, or the CDN would take care of that. So the CDN would detect that I'm trying to download this video content on an iPhone, so it would send me HLS. I have a Microsoft device. Another user has a Microsoft device over here. When it polls the CDN, it would say, okay, well, let's send him Flash, or let's send him some of the other Microsoft protocols. So our encoders support this RTMP, and we've done some tests. We have clients that are using it on some of the popular CDNs. So you know, we comply with the Adobe standard, so it should work with any service. You know, Justin TV, Livestream, Ustream, Akamai are some of the popular players that are out there. We can, you know, YouTube. We can stream video live to YouTube. So, you know, so here's the block diagram of that. So, you know, again, getting the video up to the CDN, you know, we might want to, we can send an RTMP. We can use other protocols if we want some forward error correction in here and allow the CDN to convert to RTMP for Adobe Flash. So there's a million different ways to set up these networks. And we would ask you, you know, as part of our discovery process when we engage a client is, you know, we ask them, you know, how big is your audience? You know, is it internal? Is this just for on the corporate network? Do you have a lot of remote employees? Do you have viewers, you know, distributors that you want to train, customers that you want to receive your video content live? We can help you with that. You know, make sure that you have the proper bandwidth, choose the appropriate CDN, that sort of thing, and we can help you with all those decisions. So let me move forward here. So here is, you know, at VidOvation, you know, my 30-year career, a lot of it has been spent in the broadcast market. We do a lot of work in corporate America or on the enterprise. Things are converging where the IT is everywhere. So video now has become, you know, packets of data on the network. It's less and less proprietary video formats. Everything gets packetized and put on the network, whether that's fiber optics, the public internet, or satellite. Depends on the quality or the urgency of getting those packets through the network. So, but you know, we still live. There's still systems that are you know, specifically for the broadcast market, and a lot of gear in the broadcast market uses the ASI format. So what's nice about our encoders is, you know, we can take an HD SDI video input or an HDMI video input, and we can convert to IP, of course, in one of numerous protocols that I've mentioned, or we can transport it out as ASI. And a lot of legacy or even current broadcast television equipment still uses ASI ins and outs. So that's a very handy feature that we deliver, not only an IP out, but we have ASI out. So in this case, we can encode and then hit a microwave transmitter. And, you know, baseband video is no longer put through microwave. It's going to be an ASI or a form of an IP or a compressed stream going through the satellite. And you know, we make these encoders as standalone encoders. We can put them in an open gear chassis. What's nice about these little standalone encoders, you know, these trucks, they don't have a lot of room, so we can squeeze this in somewhere and fit it into the truck. If the truck already has an open gear chassis in there with other gear in it, and there's an empty slot, we can put our H.2s or HDSDI encoder to ASI in one of those slots and give that capability. Then here's another application. So we make these gateway devices, as we call them, where we can convert to and from ASI to Ethernet, Ethernet to ASI. So an ASI stream can have anywhere from one to multiple compressed MPEG streams on it. And what we do here is, with the gateway, we split them out of the ASI stream and convert them back to Ethernet. So it's just a bridge between ASI and Ethernet. The same compressed stream is on both, just kind of breaking the ASI stream apart, taking the streams out, and then putting them in an IP transport stream, and then converting them back to ASI. So here you have a head end or a control room, and the satellite farm is, across town or on a mountaintop. And how do we get to it? So we could send through public internet. I mean, we would prefer to see, like, direct fiber optic connection or a telco connection, but sometimes that's not available. So in this scenario, we probably would want forward error correction on to put it through if it was the public internet, or even every network at some point, some place is going to drop a packet, or a packet will get way out of sequence. And so you may want forward error correction. But you see here, so we can bridge or extend the ASI via IP by using these gateway devices. And then over here at our satellite uplink and downlink, we can convert back to ASI. And we can do this bidirectionally. Some of these links might be uplinks, some of them downlinks. So we can extend the distance from the studio to the satellite farm. Here's another application. So we're closer to it. So like with the ENG truck, with the microwave truck, the encoder is we don't have this network in between us, but so the satellite modulators often want an ASI input, and you have your encoder outside of it. Our encoders are very price competitive, high performance. We can go head to head with some of the big boys, Fujitsu, Ericsson, and the like, Tandberg. So we have hundreds of these encoders, thousands of these encoders deployed. So here's another application. So some kind of receiver bank. Again, this could be satellite, it could be a cable head end, spitting out ASI, and then we want to bridge to Ethernet for monitoring. We just want to take a tap off of this, so we want to monitor what's going on our cable TV head end, take an ASI feed out of there, put it over Ethernet, and then we can view it remotely from another location. And you can see here we have the ASI decoder that would sit in here, and then the ASI bridge between a gateway bridging between the ASI world and the IP on the IP world. These gateway devices too can act as a protection switch, so you can have up to 6 ports on these, and the ASI ports they're all bidirectional ports, so you could have 2 ASIs coming in and a common ASI coming out, or 2 IP streams coming in and 1 coming out, or ASI, IP, or any combination thereof. And if one goes away, it'll seamlessly switch to the other. So it not only translates to and from IP and ASI, it can have some intelligence, do some switching. And these are what the devices look like. They can go in an open gear frame, something like this. We can do 20 channels of encoding on in 2 RUs, or that's 10 channels per rack unit. The gateway device, we have 6 ASI ins and outs and 2 gig E ports. So it's a quite diverse card. The encoders, 2 ASI outs, 2 gig E outs. You can get the cards in singles and duals. So it's a nice device. And look, like I said, we're here to educate you. A lot of people make encoders. This is our particular solution. So then here's the standalone units. These can be bought as singles and duals, and you can put 6. 3 of these can sit side by side in a rack. So 6 encoders per RU. So slightly less density, but if you don't need 20 channels and you only have 1 RU of space, we can put 6 encode channels into that space. And the gateway device is available in this packaging as well. And so I mentioned earlier, so how do we manage all these different protocols? So our stream to the CDN for Apple products, so we want to set up HLS. Our stream to the satellite, we want ASI out. We can have different protocols saved and load them. We can have cards ganged together. So in other words, we could have one channel of video hitting different encoders, doing different functions, spitting out different formats in that nice 2RU frame. So we can have 20 different encodes going on, so you can have one video coming out in several different formats to cover all these applications at your master controller, your head end, and then stream those out accordingly over the web to the CDN, to your satellite. So you can mix and match. So that's the encode side. Then the set-top boxes we like are the aminos, as I mentioned. What's nice about the aminos too, that you can find set-top boxes from China for next to nothing. The problem with those is that the design will change or it will go away. The new generation won't be compatible. Amino has a very stable product life cycle. We can always count on compatibility, reliability. And it's like $200. Obviously, if you buy them in volume, they'd be less expensive. But you kind of get what you pay for with a $50 set-top box made overseas. We really like the aminos; they're nice and stable. What we do is we reflash the firmware, so we can do cut down on the latency and do our IPTV services nice and cleanly and reliably. So to get into it a little bit, I don't want to spoil some of our upcoming webinars, but basically, when we say VidOvation TV, IPTV, or video networking, we usually mean on the corporate network. We're not, IPTV can be defined as what Netflix does or what Amazon is doing with streaming video to the home. Yes, we have systems to help with that. We have the pieces to do that. But when we talk about IPTV, first off, what we really mean is video distribution on your network, whether that's a broadcaster, a corporation, as I've mentioned, government agency, military org. We can design systems that eliminate those old legacy RF coaxial distribution. Now, mind you, there's a lot of that stuff still out there. It works. It's not very scalable. These ugly, heavy coaxial cables. You need the RF amplifiers. It's not very scalable. It's hard to add video on demand capability. You're not going to be able to bring that to the desktop easily, and you're certainly not going to be able to have a nice player on the desktop. So where we really shine and where clients really champion our solution is when you want to stream your video to the desktop or stream it to a smart device, whether it's an iPhone, iPad, or other type device, Microsoft or Apple, Android or Apple or Microsoft. Those types of capabilities you can't do with these legacy RF systems. It's certainly possible to do like a hybrid, so you don't have to tear out all your coaxial. So it's working, so certain people have access to the older distribution, but we could layer on top of that some capability to stream to the desktop, the smartphone. So we've done hybrid type systems. So, and we can gradually phase a client out. In a new building or a new install, we would never recommend RF coaxial distribution. We would want to run fiber optic connectivity between buildings, run everything on the network, whether it's category cable or fiber or a combination of both. We'd want to build out a backbone that could handle the dozens or hundreds of multicast video streams, so we could help you design your building, your new facility, or upgrade your existing facility to accommodate, state-of-the-art. So, got a few more slides left. Well, here, so you can see here a little block diagram. So, we got our off-air signals, satellite feeds. Again, the CEO wants to make a speech. You could have a camera here feeding into our encoders. One important thing the studios will not let us distribute live video on the network unless we can guarantee security. So we have some digital rights management systems that the studios have signed off on, and we encrypt the stream. So people out there on the network, the fear of the studio, you know, these movies, these TV shows, it's their intellectual property. They wouldn't want it falling into the wrong hands, somebody capturing or intercepting the stream, so they're encrypted. The Amino set-top boxes can handle this decryption. We give DVR capabilities to clients. You can record. If your set-top box has a hard drive, you can record to the hard drive on it. You can record live TV on the desktop, or it could be on a storage device on the network that people share, you know, the recorded videos. So these video files sitting out there, studios get worried. Can somebody hack into them? Could they be taken home? Could somebody burn a DVD from that? So the digital rights management system that's part of our VidOvation TV or our IPTV systems takes care of all of that. So you can see up here the module DRM. The special sauce in these types of systems is the middleware. I mean, we make various lines of video encoders. We have some very low latency encoders that probably are a little bit out of the price point for a traditional IPTV or video distribution system. We have some more generic encoders that are more economically priced. But you know, again, a lot of people make encoders. But the real special sauce is the middleware. How the video is managed. What does the environment look like to the user? So what users prefer is they want something similar to their cable TV at home. They want something that looks like their satellite set-top box. I know some of our home set-top boxes are not exactly reliable. So we like to think the look and feel, the interface is familiar, but we use the aminos, we reflash, we customize the programming in the aminos, and we build a much more robust user interface, but with a similar look and feel that people can get their minds around. And you can see here, you know, EPG, electronic program guide, subscriber management. We can push games. You know, again, it depends on the application. You know, games would probably not be appropriate on the corporate network, but in a hotel for hospitality, they have those types of features. You can see here we can handle a lot of broadcasters, satellite companies. Excuse me. They will give you a stream already in IP format, or particularly Dish Network and DirecTV. You can buy a enterprise platform from them that will spit out either QAM or IP directly, or we can use an inexpensive QAM to IP gateway and get streams either MPEG 1, 2, 4, H.264. So again, we're not talking about HLS and some of these more proprietary protocols. This is for a managed enterprise network. But with that said, when we stream to PCs, smartphones, and tablets, usually, you know, a smartphone and tablet is going to be connected via Wi-Fi. Some of these devices, you know, not every Wi-Fi network is multicast enabled. Or we can give people the ability to watch corporate television from home or while traveling. There's some HR compliance video that everyone needs to watch, or some sales and marketing training video, and your salespeople are traveling. They could log in through the internet and pick up these videos, and then those would be unicast streams because they'd be going through the internet. So then we would have our mobile device server running that would then have to spit out HLS for Apple devices and Flash maybe for Android or Windows devices, and so on and so forth. So again, there's no absolute rules that, you know, okay, our IPTV system is never going to use unicast. Also, when you're doing video on demand, unless people are going to watch the same video at the same time, video on demand is usually set up as unicast sessions. So again, when people are watching pre-recorded video off of your video library and there's individual sessions, those are usually unicast streams. And a common question is, whoa, if we got hundreds of people logging into video on demand, what are we going to do? It's going to crash the network. Surprisingly, very few people will log into video on demand simultaneously. Usage is always rather low. We're lucky if 10% of your total user base will log in simultaneously. That would be a high number. But if there's certain applications, certain configurations where we need to up those usage, we would talk about that during our discovery process when we're designing the system for you, where, we anticipate a lot of video on demand. That's how our organization works. So we can set up different things, or we could just run videos on a loop on a given channel, multicast, just running in a loop. People would just have to jump in the middle. If they're 5 or 10-minute videos, it's not a big deal. They just wait till the video starts again. So there's ways to get around that popular videos don't have to be streamed unicast as video on demand sessions. We can have them running on a dedicated channel. So there's a million ways to distribute this. And again, so our main focus is, our main value adds is streaming to the desktop, smart devices, set-top boxes, inside the facility, as well as bridging to the outside world. We can even bring the internet to the TV. So in hospitality, hotel rooms, or in hospitals, they don't want to. The patient doesn't have access, or may not have access to a computer. They can browse the web through this system, through the display, through the Amino set-top box, or that's a great way of delivering, say, corporate news. That the corporate news is actually a page on a website, so we can route a certain channel to a web page to get news and event updates, that sort of thing. And then, I want to kind of wrap this up. I've been told I go kind of long. My intention was to go only a half hour, on 45 minutes, so let me speed up here a little bit. But common thing, too, is that these systems will integrate with the Active Directory on your corporate network. So certain users may only have access to certain channels. So in a DoD type applications, or video channels that have classified information, it would, when the user logs in or tries to access it, or a certain Amino set-top box tries to tune to a certain channel, that box can be assigned to certain security levels tied to that user or that appliance's Active Directory access protocol. So the IT department loves this, the DoD loves this, so you can keep your video secure. The content providers love our digital rights management. We're keeping their content secure, so everyone's happy. IT, the studios are happy, and then the users get to see live video on the network. So here's some of the applications that we support. I mentioned college campuses, education, that sort of thing, healthcare, educating patients while they're in the bed. We just had a surgery, and the patient can watch videos on their tablet or on their TV in their room and watch videos about their post-operative care, that sort of thing. Business on the enterprise, many businesses, news agencies, keep watching live video feeds is important. We can even do a mosaic, like a video wall, where we can have 2, 4, 16 videos simultaneously on the screen. So if you're a news agency, you can watch your competing news organizations and see if there's a breaking story, and then drop into that channel to get a closer look at what's going on. Community, residential, government, DoD, distance learning, digital library, signage. Another way of looking at it, these types of systems, even in our own organization, we all communicate through video more often now. People don't read as much. We want video delivered in a multimedia or video form. How do you organize all this video within your organization? It's one thing organizing it on a website to educate the public, but internally, how do you manage all these files? So these video files can be ingested into the IPTV system, and it will look at titles and metadata and meta tags, and it can help you organize your video library. So, HR department has training videos, compliance videos. We can even, IT can give HR a report that states which employees watched the mandatory sexual harassment video per se, and then find out, okay, these employees did not watch it, and the administrators can see that, get a report. Who's watching what? What's going on? Are certain training videos being watched? So just a quick overview. If you're not familiar, I flubbed earlier and said the Multidyne name. I was with Multidyne a good 30 years. My dad started that business. We were most known for fiber optic transmission at Multidyne. 4 years ago, I started VidOvation, and we have expertise in, obviously, video networking, IPTV. We're also doing a lot with wireless. We built a in-net wireless goal camera system from the ground up using a 60 gigahertz radio, a microwave radio for the National Hockey League. So that's one of my favorite subjects besides video networking. We didn't build the IPTV system for the NHL, but they distribute our goal cam video over an MPLS network from all 30 venues to Toronto. So that's another application. We could build such a system for other organizations, other sports leagues. So wireless, video networking, fiber optics. We like to pride ourselves that we're good at doing the impossible or never been done before. We built this system that didn't exist. We did the first commercial and broadcast application transmitting uncompressed HD SDI over 60 gigahertz. No one is doing that still to this day, and we just finished our third season with the NHL. The system works flawlessly. So here's some of our, I won't read these all to you, but I've personally worked with all these organizations you see here. So if you guys have any questions, well, at least I kept it under an hour. I think I went 90 minutes last time, so I apologize if I got a little long for you guys. Any questions out there? Well, we've recorded this presentation, so we will make a point to email you a link to it in the next couple of days, so you guys can get this presentation. It should have my recorded voice as part of it. So I don't see any questions coming up. So I'll let you guys get back to work. I appreciate you for spending close to an hour with us. Certainly email us. We're here. We're a bunch of engineers here. I got a master's degree in EE. We like solving problems. Even if you think your issue or your pain point might be a little bit out of our wheelhouse, if we can help you, we'll refer you to someone that can. Again, as engineers, we all love solving problems. So we're here to listen. We're here to help. So keep in touch and watch for an email with a copy of this presentation. Thank you, guys. Have a great rest of the week and a good weekend. Thank you.